So today, we are going to have a lot of really, really important evidence for point number one. How has our model of the atom changed over time? We are going to be talking about a bunch of instances of people building on their predecessors' work. We're going to talk about some mistakes that led to new discoveries. We are going to talk a huge amount, like basically today is the lecture where we discuss point number 8. How did scientific experiments help us discover the structure of the atom? So today is basically, in one day's lecture, you could get all the evidence you needed to do an essay on point number 8. So if you are feeling like in the past, you maybe haven't been as on top of note-taking as you should have, it might be a really good idea to be extra on it today, especially with regards to this question. Because you probably could make it work just today if you were really, really on the ball. All right, so let's talk about where we are right now. Last we let off, we had talked about Dalton. And Dalton, in addition to his 5-part atomic theory, has a way that he imagines atoms. He imagines them as little spheres. Right? Under Dalton, an atom is a solid sphere. They're dense, they're solid. He doesn't know about any subatomic particles. People don't yet know about things like protons, neutrons, and electrons. So there's just a little ball. And the issue with that solid sphere model is it doesn't explain things like, why do atoms react in a particular way? Right? It just doesn't cover that. Solid sphere model is what Dalton believes in. And that's basically the same as what Democritus thought, right? So this idea of atoms as a tiny, indivisible, uncuttable, solid sphere is like that's been the concept of the atom since ancient times.
I know, but what's the lecture called?
Oh, today's lecture is called Elementary Particles. All right. So let's talk about this fellow, J.J. Thomson. He is a British physicist. He is an incredible teacher. J.J. Thomson is going to end up earning a Nobel Prize in physics. So do 7 of his students, including one that we're going to talk about today, and including his own son. So he's a person who is a mentor to lots of folks. He's somebody that lots of people build on his work. And he is really interested in these things called cathode ray tubes. Now, what a cathode ray tube is basically it's a tube full of blood. It's a glass tube. And you suck all of the air out of the inside of the tube. So inside the tube, it's just a vacuum. There's literally nothing in it. At one end of the tube, you have a metal plate. At the other end of the tube, you have a metal plate. And you can connect a strong, like a high-powered source of electricity to these 2 metal plates. And there's a really interesting thing that you can see happen when you do this. There's something that seems like it's moving from one of these plates to the other plate. And that's what he is experimenting with. He's experimenting with these cathode ray tubes.